the recording. We'll share the screen. And here I urge you to consider the American Society of Safety Professionals. They have a membership for students. So you pay maybe $15, no more. You receive their magazine, and on your resume, you can write that you are a member of the safety engineering professional here, an ASSP member. And that matches our interest in that class. So please go and explore that site. It's ASSP.org and become a student member. Many of the students taking our class here have been members of that society, and as they found jobs in their individual professions, they also were safety engineers, and that's an interest we are sharing together. Okay, I'll try to add people, allow people into the room here. However, we are supposed to be meeting face to face, so please keep that in mind. Right now, I'll try to restore the situation here in the view. Speaker, gallery, then we need to maximize it. Speaker. Okay, now we're back in business here, and I'll start. We are recording, and I'll share the screen now with our class itself. No, actually, we are having a problem here. Share, but maybe I have to share for our class here. Yeah. All right. So here is our second chapter in our class this semester. And what we are going to do today is cover the topic of natural disasters and how they affect engineering structures in general. So it is not that we are studying like geography, natural disasters, but our interest is what kind of mitigation effects we use to mitigate the consequences of natural disasters. If you don't know how natural disasters affect engineering structures, then of course we will not be able to design features that mitigate those effects. Natural disasters occurrence, as we all know, is part of the dynamic life on Earth, and they are somehow out of the control of human beings. They occur also unexpectedly due to environmental changes coming, like the example of the Fukushima accident was caused by an earthquake that caused a tsunami that affected the nuclear power plants in Japan. It could be, tsunamis is a different name for tidal waves, of course. Tsunami is a Japanese name for harbor wave, and that's because the fishermen in Japan noticed that their harbors become targets of the tsunamis, and with a very, very devastating effects, as we have all seen probably on TV in the Fukushima accident. Hurricanes also cause damage to human structures, cyclone, typhoons. I'm going to ask you a question in the assignment to tell me what's the difference between hurricanes, cyclones, and typhoons. Anybody knows it here right now? It depends, as a hint, on the geographical location, but they're the same thing. It's interesting just to know that in different locations, we give them different names. Obviously, in the Midwest here in the United States, we worry about tornadoes. Other parts of the country, of the world, worry about volcanic eruptions, mudslides, earthquakes, and I'll add here flooding and droughts. And we are living in a period of time where droughts and flooding are occurring in different parts of the world. Some people suggest it has to do with global climatic change. As safety engineers, I recommend, again, you join the Society of Safety Professionals. The word disaster has an etymology. What's the etymology? It's the origin of the name. It comes from the Latin aster, Aster is basically means this star. And as another name that comes from aster or star is asteroids. So in that case, the word disaster originally means an unfavorable aspect of a star. So the astrologers in the olden days simply would make predictions based on the position of the stars in the sky and the part of the constellation that we were born in, and try to make predictions for the future. Basically, it's named astrology, that thought that heavenly bodies in the sky affected terrestrial events. Whether you want to believe in it or not, it's up to you. Our interest in that natural events can be the initiating events, and we'll use the word initiating event in a quantitative way later on for accidents affecting man-made structures. Floods, for instance, can cause dam failures. Hurricanes can also cause flooding. In the United States, when they happen, they cause dike failures and flooding, and people can lose their lives. And of course, property damage is also huge. Depending on the geographical location, a tropical system can be called a hurricane, cyclone, or typhoon. I'm giving you the answer to a question that have you explore itself. As they affect human structures, they can lead to even more serious accidents. So the flooding now gets compounded by total destruction. The example that we can use right here is the earthquake leading to the tsunami in Japan and affecting the flooding. A new type of accident that was not considered earlier, of flooding of the nuclear power plant and then causing it to melt, a core meltdown. And in that case, we identified in the previous chapter the concept of a LOCA, or a loss of coolant accident in nuclear power production. If you lose the cooling to your power plant, you can melt the core and release the radioactivity. So what do we do about that as engineers and professionals, as humans? We add to our any engineering structure, be it bridge or a skyscraper or a nuclear power plant, in our case here, what we call engineered safety features. And there is an acronym for this, ESFs. And the idea of the engineered safety feature is not to totally prevent the natural event from occurring. We don't have control on those natural events, as you can tell, but to mitigate their consequences, even when they occur. Mitigate means that we reduce the level of damage and especially the loss of life. Life is very precious to us humans in general. This gives us to some kind of quantification of what we are going to say the societal risk. So in the analysis of accidents, we define the risk, and each kind of an event has its own risk. As we go along there, this is a picture of the largest cyclone ever to happen in recorded history. They named it Cyclone Bola. It happened in 1970. It was the deadliest cyclone ever recorded. It caused a surge from the water in the oceans in the area of Bangladesh on the Ganges River, and it resulted in 500,000 people, a single event of a hurricane. And maybe you've seen in the news in our lifetime, a tsunami that happened also in Indonesia and Malaysia, and it caused about 250,000 casualties. This was the worst of any of them happening in the, of course, Southeast Asia. All right, so here we try to create a comparison now, and that comparison is going to help us define the concept of risk. So whenever we construct an engineering structure, we think about what is the risk involved in our design. And if our design is not sufficiently safe among from the perspective of the level of risk, then we really need to implement those engineer safety features and reduce the amount of risk to a level that matches our capability in terms of spending money or the economics of the process. This is, I mentioned last time, the WASH 1400 report that was that is also called the Rasmussen report. The author was Norm Rasmussen, the head of nuclear engineering at MIT at the time, 1974. He issued the nuclear safety study, and he came up with a very interesting statistics here. He went to what's called the vital statistics. Vital comes from vita, which is in Latin life statistics. And you could see here that he considered the different accidents that happen in the United States. So, he listed here how many fatalities or loss of life that happens per year in the United States. And then he took that number and divided it by the population of the United States at that time. You can say about 300 million people. Now we are larger in that case. In the United States, we are about 320 million people. He divided that number by the population in the United States. The units here, notice here in engineering, we watch our units. So this is fatalities per year. And then when you divide by the population of the United States, you get a number that is now fatalities or deaths per person per year. When you give those units of fatality per person per year, you are estimating a quantity that we call the risk. Now, notice here, last time we suggested that when we describe accidents, we can use the frequency or a likelihood. Here, we are describing it also in numbers of deaths. It could be not just loss of life. It could be morbidity, like people getting sick, say, from air pollution, from coal, or it could be a loss of money. Dollars per person per year is also a measurement of what we call risk. So risk is not a probability. It has units. It's a frequency per person per year. And you notice here that the leading cause of accidents in the United States in terms of risk is motor vehicle accidents. And you know that, of course, we spend quite a bit of effort and money trying to make our transportation system safe. But nevertheless, you'll find that motor accidents happen. And there is a great deal of effort in mitigating those accidents. You will quantify it later on in more detail. But we started, for instance, with the seat belts, and we started adding the airbags, and we added video cameras and so on. But each time we add safety features, you'll find that we are going to spend money. And that money is going to be spent to reduce the risk. So the risk can be reduced by some investment, but we cannot go and spend unlimited amount of money. The economy will fail in that case. So you'll find that you have to justify the spending of money to reduce the risk in any engineering activity in general. By the way, interesting enough, the motor vehicle accidents were in the year 1969, 56,000 people. They didn't change much, but the interesting thing is that half of these accidents are due to driving under the influence, either of alcohol or drugs. The second cause of accident in the United States of risk in that case is accidental falls. Older people say skidding and falling while having a shower in their bathroom, unfortunately, or people getting on the roofs to shovel snow in the winter when there is a very thick thickness of snow. You'll find that this is the second cause of risk. Now let's talk risk in the United States. Fires and hot substances, drowning, poisons, firearms, machinery, air travel. You notice that air travel doesn't have a very high risk. It's less risky, in fact, to travel by air than to travel by motor vehicles. In fact, here in motor vehicles, the accident can be caused by not yourself, but the other person involved in the accident. Falling objects and water transport, electrocution, railway, lightning, hurricanes, tornadoes, and all other causes are listed here. You add all of those fatalities, you divide by the population of the United States. And here we have a 4, 10 to the minus 4, meaning that's 4 in a 10,000, 4 people every year on the average basically would die in other causes, but from accidents. So you could see that later on, we have some control on some of those accidents by adding the engineer safety features. I might ask you for some nice exercise, looking maybe for the latest number for available to us 2020 maybe, and they don't have the statistic for 2022, obviously, and the population of the United States, and then estimate the risk in that case. I'll give you something along the motor vehicles accidents in general. So this is the motor vehicles risk statistics from the National Highway Traffic Safety Administration. They have a different number, obviously, here. 41,000 people die every year in accidents. And it is not just death that we worry about. You also have to worry about injuries. Imagine that 2.5 million people every year, 2.5 million people in the United States get injuries in automotive type of accidents. As I suggested, some of those deaths, unfortunately, can be controlled. 12,000 of those 41,000 are related to alcohol, not necessarily drugs too, but just alcohol. And speeding causes 13,000 deaths. Injuries, this is the number of injuries here. And alcohol-related deaths are 32% of the fatalities, and speeding is 32% also, like the case of accident. So here we're trying to say that engineering devices that we use, from airplanes to trains to to automobiles, are a source of risk in our society. There is a history of the accidents at natural events. Now we are going to concentrate on natural events. It goes back all the way to history. If you go back to history in the legends and history of different nations in the world, you usually come to the Great Flood. And at the time of Noah's and Noah's Ark, in the Judeo-Christian and Islamic accounts, supposedly in the 1600 years after the creation of Adam and Eve, the human race became wicked and deviated, and basically a great flood happened to punish them. Noah, as a prophet, was inspired to build an ark where he had a male and a female species of each creature on earth, and he survived the flood. Over 40 years and 40 nights, rain flooded the earth. Some people suggest that it may have been a comet impact that raised the level of water in all the oceans. Some people suggest that it was the Atlantic Ocean flooding the Mediterranean and the Black Sea area. Historians and archaeologists are trying to solve that problem in general. What the story tells us that after the Noah's Ark settled on top of Mount Ararat in Turkey, Noah sent out a pigeon, and the pigeon came back actually with an olive branch, and hence this is the origin in the story of an olive branch as being a symbol of peace in general. All right, so this was a historical natural event, how it happened. In fact, I find that in the Mediterranean and Black Sea beds that there are some kind of archaeological sites underwater. It tells us that the level of water in the oceans is much higher than it was in the past. Now we have to learn about those accidents that happens in the world. And maybe as an exercise, you could can ask you to try to classify them according to the level of risk. Associated with risk, of course, is a consequence that happened from those natural events that eventually caused, of course, damage to human life and, of course, economical damage too. It turns out that the world sometimes is subject to volcanoes, volcanic eruptions. And I urge students who haven't done it. I was discussing it with a student in my office today. It was interesting to visit the site of Yellowstone, the Yellowstone Park. Rent a car, don't go with your own car, you'll ruin it on the trip, but find your way to the Yellowstone Park in the United States. You will be in the caldera or inside really the volcano itself at the Yellowstone Park. The largest volcanic eruption to our best knowledge really happened there at that Yellowstone National Park in the North American continent. It happened in the state of Wyoming in the United States. There were two large eruptions, 2.2 million years. BC stands for before Christ, and another eruption at 600,000 BC. We are still at a great risk of that volcano erupting again. When is it going to happen? We cannot tell. We don't know. In fact, NASA is trying to cool the magma under the volcano so that that would reduce the possibility of an event in that case. In terms of the fatalities, well, the human race hadn't increased in the population at the time, so the consequences in terms of deaths is a question mark. We don't know. Humans may not have been really alive all over the place. But if you go to that Yellowstone Park, you will find very fascinating displays from nature, like geysers, mud holes, fumaroles. Fumaroles are holes in the ground that are basically releasing gases, particularly sulfur gases, hydrogen sulfide, H2S, the bad smell of rotten eggs, and SO2, which is the sulfur oxides in general. And 600 cubic miles of ash were ejected into the atmosphere. Now, let's go a little bit to recorded history. In Greek history, they mentioned the island of Strogli that blew up in a volcanic eruption. And the eruption called it tsunami. In Japanese, I suggested that in Japanese, it's harbor and nami. If we have a Japanese person, please correct me. And as it happened on the island of Crete in the Mediterranean Sea and destroying the capital of a whole ancient civilization that was called the Minoan Empire civilization. Today, if you visit that area, it's called the Santorini. And Plato, as you know, like a Greek philosopher, may have referred to it as the Atlantis, city of Atlantis. This happened from 1650 to 1410 BC in the Mediterranean area, and it caused the death of a whole population of that area of Santorini. 100,000 people died in that case. In history also, in recorded history, we know that in North Africa, there was an empire that fought the Roman Empire, if you heard about it. Today, it's the country of Tunisia and Algeria, Tunisia in particular. You may like to visit these areas over your lifetime at least once. And the civilization was called the Carthaginian civilization. Their leader was named Hannibal, and history tells us that he fought the Roman Empire He used elephants in that case in his army. He did a fascinating feat with his army and his elephants in crossing the Pyrenees chain of mountains. That would be between Spain and France, headed to Italy and fought the Romans there, but eventually the Romans defeated the Carthaginian empire in general. The elephants were killed in avalanches in the Pyrenees. You know, avalanches are snowfalls. And I don't know whether it was the Alps or the Pyrenees. I think it's he had to go through both the Pyrenees chain of mountains that's between France and Spain, and then between France and Italy, this is the Alps mountain. And Carthage, it's at present day Tunisia. It happened in 218 BC before Christ. And the avalanches killed 20,000 people in his army. That was devastating, of course. Then we go to the Roman Empire itself. In the Mediterranean, there is a mountain called Mount Vesuvius in the south of Italy. It was buried under 14 to 17 feet of tephra and pumice and destroyed the city of Pompeii. And that happened, and it buried it under 60 feet of mud and volcanic ash. Later on, they discovered that another city also, Herculaneum, and the gases from the volcanic eruption suffocated and buried the population in general. Vesuvius was the first volcanic eruption described by its survivors. We even know the dates. The exact date, it happened in the summer, August 24, well, 3 days ago, in the year 79. This is now not BC, before Christ. This is AD. This is ad dominion, meaning after Christ. And we know that the population was very small. 3,000 people succumbed in that event. So you could see here that we have events that affect us, and we have no control on volcanic eruptions. All we can think about is not build our engineering structures too close to volcanoes. You don't go and place a nuclear power plant on the slopes of Mount Vesuvius, for instance. We know also about earthquakes that happened in the area of Syria and Antioch. This is near now a city called Antakya in Turkey. The earthquake was followed by a fire. Well, when human dwellings are destroyed, they may be cooking and the fire starts spreading. It happened in Japan also in one of their events there, an earthquake burned the whole city. That happened in 526 AD, and that one was very devastating. It caused the deaths of 250,000 to 300,000 people. And that's why when you visit the temples, Roman temples or Greek temples in the Middle East, you'll find them mostly, and Egypt, you'll find that they were basically destroyed by earthquake. Now we come to what we are going to define in more detail later on, a magnitude 8.5. We'll see that there are different ways of assessing the seriousness and the energy release from those events. We have different scale. One is called the magnitude scale, 8.5. We'll define the one for Fukushima later on. And when we are engineers, civil engineers, building structures, we have to decide at what level of an earthquake happened in that site historically and design our structures accordingly. This happened again in the area of Syria. Aleppo is a city along the Mediterranean in Syria. 230 people perished in that event. In Egypt and Syria, again, all their ancient temples were, not all, but most of them were destroyed in 1201 AD. That was what people call a swarm of seismic storm, means a swarm, many earthquakes happening all together. Oh, now that started causing lots of damage. 1.1 million people perished. Another problem that happened in terms of natural disasters is in Europe, the bubonic plague. That's a plague, as you know, is a disease that is spread by fleas and the fleas are carried by rodents. And the disease occurred initially in the city of Alexandria, Egypt, along the Mediterranean, but they had trades in ships, and the disease was carried into Europe. And look how many people it killed. 75 million people, that is the estimate, when the world population was much less than what we have today. Just for in comparison, the Spanish flu that happened in 1919, very similar to what we have today, the COVID-19, caused the deaths of, this one caused the deaths of 75 millions of the world population. The 1919 Spanish flu, it didn't happen in Spanish. In fact, it started in Kentucky here in the United States and spread to the rest of the world by soldiers going to Europe and fighting on the battlefield there. The Spanish flu caused the deaths of 60 million people. The plague is a bacterium called the Yersinia pestis bacterium. It is not even a virus, and it wiped out 30 to 60% of the European population, or the world population, in fact. So the fascinating thing is that your parents, my grandparents, grandparents, are people who survived that bubonic plague that spread all over the world, but the plague itself generated immunity. And we have all of us here, because we are here, still alive here, we have acquired immunity from our very grandparents. The rest of them, unfortunately, perished. I warn you that bubonic plague is endemic here in the United States. It exists out west in the rodent population. So people are warned, if you travel west, say you go to the Yellowstone Park and visit it, not to feed the ground squirrels because they carry the disease. They can bite you and give you the bubonic plague. So please don't get the bubonic plague. That's a risk that we have all in our society. In the North Sea, we know that in November 17, 14, 21 in the Netherlands, a huge storm occurred and flooded the low areas. The Netherlands means the lowlands. The Dutch have acquired their land by drying the marshes along their sea coast. And you know the story or the legend of the little boy who plugged a leak in one of those dikes to prevent really the dike from collapsing and killing the population. That caused the death of 10,000 people in 1421. See, it's not a BC anymore. The deadliest 8.0 magnitude, we'll see that magnitude means that that's the signal, the magnitude of the signal that we get on a seismograph, but there are different magnitudes, the Richter scale that you heard about, we need to define. Basically, the deadliest 8 magnitude earthquake happened in China. And we'll see later that China is prone to huge destruction from earthquakes as well as flooding. And we'll see that in that case, when they design human structures like the Three Gorges Dam, we have to design it to withstand the worst earthquake that happened historically. That's one, look here, a single earthquake leading to the deaths of 830,000 people lost in human life. A 2-week storm system attacked England in 1703 AD. Japan in particular has been a target of many of those tsunamis, which we said are tidal waves, and they affect particularly harbors where fishermen would be having their boats. It happened in 1707, caused the deaths of 30,000 people. Very similar, close to the 18,000 people that died in Japan from the tsunami with the Fukushima earthquake. It's very frequent in Japan. We have to admire really how the Japanese can do recover from all those calamities, and they come up and back again into their civilization in general. In Calcutta, India, a typhoon event happened. It was also an earthquake that caused the deaths in 1737 of 300,000 human lives. In Lisbon, Portugal, they were hit by a very strong earthquake, 9 on the magnitude scale, and we'll study that in more detail. It destroyed and devastated ports in Spain and Morocco, 70,000 deaths. The Great Hurricane of 1780 damaged 100 merchant ships in the West Indies. 20,000 sailors lost their life in that case. Yellow fever epidemic, so you could see another form of natural disaster is the epidemic. The COVID-19 is not something new that our human race is facing. We mentioned the bubonic plague earlier on, but this one was the yellow fever, and the yellow fever is transmitted by a vector, which is nothing than mosquitoes like malaria. In that case, that happened in the United States. In fact, yellow fever, 5,000 people died in that case. In Missouri, the United States, here in 1812, we had this an earthquake that happened very close to us in the sense that it's south along the Mississippi River in an area called the New Madrid Fault. And that earthquake was so strong, 7.8 in magnitude, it reversed the flow of the Mississippi River. Instead of the river moving from north to south, it moved the river temporarily from south to north. It was basically an aftershock of 8.8 on what we are going to call the Richter scale. And 1,000 miles away, the earthquake affected the church bells in Boston, Massachusetts, and the bells on churches rung from the motion of the earth from the earthquake. Now, the damage in that case was very minimal because in 1812, the population density in that area was very low. In the area of Indonesia today and India, a volcanic eruption called the Tambora in 1815 AD caused the death of 80,000 people. A cyclone happened in India, in Andhra Pradesh. It triggered a 40-foot wave destroying ships and a village, drowning 20,000 people. And in that case, totally 300,000 people died there from that earthquake. The Indonesia is part of the tectonic plate of what people call the ring of fire around the Pacific Ocean, where the tectonic plates are rubbing against each other. And in that case, in Indonesia, other volcanoes, the Krakatau, or some people call it Krakatoa, a small island totally disappeared. The pyroclastic flow, pyroclastic, pyro in Latin means fire, basically hot gases that come down the flanks of a volcano and basically can burn, totally burn villages and destroy the whole thing. The eruption was heard 3,000 miles away. It burst the eardrums of people 40 miles away, and that caused the death of 36,000 people. China, as I suggested, is prone to earthquakes and flooding. The Yellow River flood in 1887, the flooding covered 50,000 square miles. Look at the death toll there, from about 900,000 to 2 million people in a single event. Well, of course, it has to do with the high population density also in China. So in China, they worry a bit about earthquake events causing damage as well as flooding. And that's why they have built the Three Gorges Dam as a way of dealing with these flooding events. Right now, unfortunately, global warming is paradoxical. They are having a drought. And here in the United States, we have parts of the land in Texas that are subject to flooding and some parts of the land that are like California that are under a drought. In Japan, another volcano erupted in 1888. Hundreds of people died, but we don't know exactly how many. The deadliest natural disaster for us in the United States was a hurricane that hit the city of Galveston in Texas. It killed 8,000 people and basically leveled the city to the ground. More recently, in 1902, Mount Pelée destroyed the whole city of Saint-Pierre. It was considered the Paris of the West Indies and caused the death of 20,000 people in the island of Martinique. This is a French island. Turtle Mountain in Canada, Alberta, basically melted out as a result of a change in temperature, sent 30 million cubic meters of limestone in a landslide. And mudslides are very common if you read the news in South America, and that caused only the death of 70 people. The San Andreas Fault is a big threat of earthquakes in the United States. It happened twice in the city of San Francisco, where the tectonic plates, the Pacific plate and the American plate, rub against each other with a subduction zone, as it's called. One tectonic plate goes under the other one, and the friction there creates heat, so it melts the rock, and then almost like an elastic band, when it snaps, you get a very major earthquake. It happened in San Francisco twice, 700 people died, but it destroyed 500 downtown city blocks. Imagine here, Champaign-Urbana would be totally wiped out to the ground. They had gas lines, natural gas lines, and that caused fires all over the place. Fighting the fires had the firefighters dynamite buildings to stop the spread of the fire. And the problem was even multiplied by the fact that the water lines also broke underground. So the firefighters didn't have water to extinguish the fire. Another earthquake happened in 1911. This is now the age of maybe your grandparents in Tajikistan. And first interesting, in Italy, there was a war going on between Austria and Italy at Mount Marmolada. There were avalanches that killed 10,000 soldiers, not fighting each other with guns, but just an avalanche happening. In the province of Gansu in China again, you notice when this earthquake and floods happen in China, at Taiwan in China in 1920, that is immediately in the hundreds of thousands, 235,000 perished. I'm going to go a little fast here. A deadly tornado moved from the Missouri to Illinois. Actually, it passed southwest of Champaign-Urbana, the city of, let me see, I think it's a city is Sadorus, yeah. And it destroyed all the structures in its path, and so it can affect people anywhere in the United States. And some report from the papers is that somebody saw a cow was hurled into the village restaurant. It killed 695 people. And our area of the world here is very prone to particularly tornadoes. The areas along the Gulf of Mexico are prone to hurricane, but so is the Atlantic areas, like Hurricane Sandy affected New York and New Jersey recently. The worst single natural disaster in history occurred on the Yangtze River. Basically, they had a summer monsoon in 1931. 1 million to 3.7 million people perished. Again, I say that when it happens in China, it is extremely devastating. A hurricane known as the Long Island Express, it attacked Long Island on the east coast of the United States, 600 people. Japan has not been stranger to earthquakes. I'll go fast here for the ones that have a large number of events. In the United States, there was a 9.2 magnitude earthquake. They called it the Good Friday earthquake. 118, 125 people died and thousands were injured. And here is now our lifetime in Bangladesh. In 1970, there was a cyclone that caused the deaths of 300,000 to 500,000 people. Tangshan, China in 1976, about 655,000 people perished. There was, interestingly enough, the super typhoon, the largest typhoon ever to happen, happened in the Pacific Ocean in 1979, and nobody died. Oh, wow, that's very fortunate. The hurricane or typhoon stayed offshore, right away from land, so it didn't cause any deaths. In the United States, again, Hurricane Mitch, within 6 hours in Honduras, Nicaragua, Central America, caused the deaths of 9,000 to 18,000 people. Let me go fast here. In the Middle East in 2003, in Iran, an earthquake happened and destroyed structures built out of stone, killed 43,000 people. Another earthquake, now that is in our lifetime. The island of Sumatra, Indonesia, before Fukushima. In 2004, a tsunami happened and in Indonesia and caused the deaths of 225,000 to 230,000 people. So earthquakes in the ocean can cause a tsunami and kill people. In the United States, in our lifetime, in August 2005, Hurricane Katrina generated 175-mile-per-hour wind, and it caused the deaths of 1,836 people. In our lifetime, in Kashmir, Pakistan, 2005, 75,000 people. In the South United States in 2008, a Super Tuesday tornado, just many of them happened that day. And I'll go to the end here because we have only 3 minutes left. And in the United States in our lifetime too, this was Hurricane Sandy. It happened along New Jersey and New York in 2012 and caused the deaths of 75 people, but lots of destruction. The power lines above ground where they should be, when they should be underground, caused the deaths of 75 people. Another typhoon happened in the Philippines, Vietnam, and Micronesia. 4 million people were displaced of their homes because their homes were flooded and destroyed. In the United States, 2017, in our lifetime, more than 33 people died, but it caused the deaths of $100 billion residential loss. Now you find that the number of deaths in these different locations of the world differ from one country to the other. And you immediately notice that it depends, of course, on the population density, but it also depends on whether engineers and scientists have implemented some form or the other of those engineered safety features that we mentioned earlier. So in summary, then, in the 1 minute that I'm left here, you'll find that the human toll or death up to the year 2040, you find that the most serious event that can cause human death is hurricanes. In the Caribbean, Bangladesh, the Gulf of Mexico, about 1 million people when they occur at the time. Volcanic eruptions, what follows after it is tsunamis. No wonder the Fukushima accident and in Japan, the toll deaths is 300,000. So you have volcanic eruptions, hurricanes are the most deadlier one. Earthquake also are extremely deadly. Tsunamis, 300,000. Hurricane and land and mass slides, they occur primarily in South America. You'll find that these are causes of human death. I'll ask you just to go over these and maybe suggest other events that I could add to that list. In essence, the point that I'm trying to raise is that we have no control on those events. but as humans, engineers, public servants, in designing any engineering structures or any human structures in general, even like railroads, for instance, we have to account for these events by their level of incidence and the degree of damage that they can cause. Some events we have no control on, and some events we have a control on. So next time we talk about astral impacts. Astral impacts in when an asteroid or a meteor can hit the Earth. We have no control of this and can cause basically a large extinction, like the dinosaurs died with an event that was an astral event. Astral here again means that it comes from the stars. It's so we leave that for next time, and I'll hope that the system recorded itself, and in that case I'll publish it on the Illinois media site. In that